So slag entrapment, porosity, blowholes,
স্যার
lack of fusion. Yes, who is it?
আরেকবার একটু বলতে পারেন? মানে খুব ঝাপসা আসছে তাই জন্য বলছি।
Okay.
পোরোসিটি, ব্লো হোল।
Slag entrapment, porosity, blowholes, lack of fusion. This happens when the arc is not stable. Okay. So uh, and also because of these things, the welding nugget we get, welding nuggets are the type of lump type of forms happens on after the welding process. Now with chipping hammer, you strike on those nuggets, clear out the slags, and then you will find out if the arc is not stable, then you will get the slag entrapment, and which will result a brittle joint. The porosity of course means lesser strong. Blowholes quite similar of porosity, but the volume of the vacuum spaces are small, and lack of fusion. Okay, these terms I think already known to you because you have learned it in primary manufacturing processes in welding chapter. You have learned these effects. You know the terms, so I am not discussing them at all. And later on, when there is a welding defects chapter in module number 4, then also we'll discuss all these things again in a elaborated way. Now, for stable arc, the welding unit should be such that a little variation in arc length should not extinguish the arc. Suppose when you are doing MMA, manual metal arc welding, okay, so it is the manual process and the arc gap, I mean the arc length and the gap or the gap between the electrode and the job cannot be maintained same, they will fluctuate. Now stable arc means for little fluctuation the arc should not extinguish. So the continuous and proper emission of electron from the cathode and thermal ionization of the arc column should be ensured. So what we have to do? Continuous and proper emission of electron from cathode and thermal ionization of arc column should be maintained. Okay. Now then what we can do for that? We have to use proper flux coating on the electrode with the arc stabilizing elements which can help stabilizing the stable arc. In our previous classes we have discussed which elements on the flux can provide or can help a better arc. So those arc stabilizing elements to be used. Now there is a phenomenon, these elements already discussed, stabilizing elements like Al2O3 iron powders, okay, wood flowers that produces CO2 which also helps to maintain the arc, ionizes the air. Okay, now there is a problem, there is a very huge big problem when you do arc welding, and that is called arc blow. What is arc blow? When you are maintaining arc welding, when you are maintaining arc welding, then if you use DC current, so this happens when you use DC current. Okay, now when you use DC current, then a problem occurs. The electrode and the job, this gets magnetized. I mean, the magnetic field is produced around the arc. Magnetic field is produced around the arc. So, what happens because of this magnetic field? Because of this magnetic field, the arc gets shifted. The shifting may be towards side, or maybe forward or backward direction. And as a result, you want heat to be produced, that region will be shifted to sideways or forward or backward. And this mainly happens around the edge of the workpiece. Like, the phenomenon is like a strong wind is blowing and shifting the arc. It seems so, but it happens due to magnetic field produced by uh, mainly DC current. Okay, so this is a very big problem, because where you want the penetration will occur the side of your desired location. It is a very big problem, and it happens only in DC. In AC, arc blow does not give you much trouble, because the current polarity continuously changing in AC. That's why the magnetic field does not get produced. Even if it get produced, it changes its direction, and as a result, it doesn't travel you much. In DC, it travels a lot. Now, the factors because of which are responsible for affecting the arc blow. So we are basically summarize. So number one, magnetic field produced due to current flow through arc, presence of bus bars. Sorry, this is BU
Sir, flow through.
arc, comma, in presence of bus bars in the neighborhood of welding place. Do you know what is this bars means? When you cut material or prepare edges by filing operation, some very sharp edges are produced. When you cut by sawing something, when you cut in milling, you have seen we need to make smooth by filing it. Otherwise it becomes very dangerous because of some uh, type of sharp edges produced. So those are basically called bars. Now as they are kept upwards from the parent metal, so this attracts the arc and the arcs gets bent towards them. So at the bottom, when where the penetration is required on the groove, the arc does not reaches, the arc connects to the bars. So as a result, does not get the penetration you required. The arc does not melt the material in the groove, but it you know produce heat beside the groove on the edges. Number two, operating multiple welding heads affecting each other. Multiple welding head means, suppose you are going through carbon arc welding with carbon electrodes. Now there, two simultaneously two number of electrode using is a very normal phenomenon. So if such type of multiple welding heads are working, then one electrode may disturb the other. So if this arc blow get increases, then it results increased arc blow results unstable arc, poor weld bead, lots of undercuts, erratic weld deposition, spattering, and slag entrapment and porosity in the weld. Okay, so these are the things may occur. Now, how can be decreased or eliminated these problems? This can be eliminated. Arc blow can be decreased or eliminated by this following methods: changing the position of earth clamp, you have to put the earth clamp away from welding area. you have to produce short arc. You have to use short arcs, eliminating presence of magnetic materials around the workpiece. Number 4, decreasing arc current. And number 5, decreasing the travel speed or preheating the workpiece before
or
welding. Preheating the workpiece before welding. Okay.
thank you, sir.
Aman, roll number 86. Roll number 86. Please rename your Webex account. Put your roll number at the front, at the beginning, and place your name on the last. Same thing applies to Rahul Ranjan, roll number 78. Please put your 7-digit class roll number on the first, then put your name on the back, just like the others. You see, Aman, Moinak, Rahul, and roll number 96, roll number 79. Please put your roll number, 7-digit class roll number first, 7-digit class roll number first, name at the last. Otherwise, I cannot put your attendances. Okay. Our next is arc length. Next topic is arc length, which is very, very important. Arc length. So we always have to try to use short arc length. We will not use longer arc length. We use short arc lengths. Okay. And that will give you advantages like advantages of using short arc length, like high penetration, maximum strength on the arc, minimum porosity on the weld, and maximum ductility on the joint in hedge area. Better behavior. Better behavior means better mechanical properties of alloy steels. Okay, so you must try to, keep your arc length smaller. Now The arc produces a shape like this. If this is your electrode, arc is kind of produces a shape like a bell shape. Okay, so if this is electrode negative and if your job is positive, uh, it takes a shape like this, where this area near the cathode is called cathode spot, and the area near anode is called anode spot. If you produce a good arc, the arc will take a shape of bell. Okay, now we learn the differences between AC arc welding and DC arc welding. We'll compare AC arc welding and DC arc welding. Whenever the question comes with comparison or differentiate, you must take two columns and then compare them. So in arc welding, AC arc welding, striking of arc is difficult. I mean, generation of arc is difficult. The maintenance of short arc also difficult. Except you use
So short arc making is also difficult, right?
difficult, yes. Except with use of iron powder electrode. That means when you are using the electrode with coating of some materials which stabilizes the arc, then you can do it. Just like iron powder, Al2O3, and other things we have discussed already, in flux material topic, which is already discussed. So if we use this type of materials which helps to produce a good arc, then you can use AC arc welding, and you can get short arc. Now in DC, developing and maintenance of short arc is easier than AC. Number two, no problem of arc blow, which is a severe problem. But in AC, no magnetic field is produced, and thus, you know, there is not much problem. No problem of arc blow. This is severe problem in case of DC. Number three, this arc in AC never stable. This is more stable. Number four, this is not suitable for all metal, used for welding ferrous materials. Number 4, polarity can be changed. So ferrous, non-ferrous, both metals can be used. I mean, can be welded. Number 5, this is more suitable for higher current value, less suitable with small dia electrodes. So when our requirement is very less, but accuracy is much higher, we require, then we always go for DC. So here, most suitable with smaller current and with smaller dia electrode. If we use higher current in DC welding, then that problem again occurs is arc blow. Jogesh Kumar Rajak, are you saying something? Please turn off your mic.
স্যার ওই দুটোই কি একই পয়েন্ট?
কোন দুটো?
স্যার এই যে this is suitable for a higher current value মানে AC, and DC is not suitable for higher current value, and it is not suitable for small dia value for arc AC arc welding, and DC arc welding is suitable with small dia value.
Just a second, Kumar. Let me take care of some noise.
अभी अभी स्टार्ट हो रहा है तो सारा मतलब सितंबर से तो सब जेई सब चालू हो रहा
Yeah, Shomabu, now please continue. I have not heard your
Yes sir,
question. Yeah, please.
yes sir, I was asking that are these two the same points mane for higher current value and small
No.
dia value,
These two
are
are
those the
not
same
same.
point
These
or
two
two
are not
different
same.
points?
These two are not same.
Okay sir.
See, the problem is if we use higher current in AC, there is no problem. If you use higher current in DC, then you get arc blow. Okay. Now
Okay sir.
when you require very delicate job,
Yes sir.
then what you have to do? Then you have to use always DC current, because if you use AC current in lower value of current, then there will be disturbance. There the arc will not be stable. But with lesser current value,
Okay sir.
the lesser current value, then
Hmm.
you can use DC current. And for such case,
Okay sir.
as the current value is less, magnetic field is less, and as a
Yes sir.
result,
Yes
there will
sir.
be no problem of arc blow. But
Yes sir.
you can produce proper heat in proper place in AC current. Then in the next point we will discuss, if we use AC current, then the heat produced on the electrode and on the job will be same. But in case of DC, you can shift it, you can change it.
Okay sir. So it is suitable for small dia electrode then.
Yeah.
Okay sir. Thank you sir.
Next point, number 6, bare electrode cannot be used. bare
Can you
electrode,
please repeat the type of electrode?
bare,
Bare
without coating,
electrode. That's
without
a
coating.
bare. Okay, okay.
Bare electrode cannot be used. Only flux coated electrode can be used. Now, this flux coating should be with arc stabilizing agent like iron powders. Okay, here bare and coated, both type can be used. But if you use bare electrode, you have to always produce shielding gas separately. Roll number 78, Rahul Ranjan. Please stop your mic. Okay. Number 7. As because we are using higher current with AC electrodes, that means you cannot use thin sheets. So you have to always, in AC, you have to always go for thick sheets. So thin sheets not suitable. Not suitable for thin sheets. And for sheet metal is very difficult in striking the arc. So thin sheets are not done with AC. So this is also 7. No, it is suitable for all type of sheet metals. It is, so we can write it is suitable for sheet metal as striking the arc is easier than AC, and the arc also remains stable. Number 8, the distribution of heat or the heat produced in arc equal at the electrode and the job. Heat produced is equal in job and electrode. Number 8 on DC, most heat generated on positive side, which is 66.67%. Okay, next point. This is AC, this is DC. Okay, we have ended point number 8, so it will start here with point number 9. Voltage drop is less, and that's why suitable for jobs at longer distance with longer cable. Here voltage drop is high, so cannot be used with longer cable. Now AC transformer welding set is not costly, and DC rectifier or DC generator or DC machines are costly, and the maintenance is easy, also easy. This maintenance required is high, and this is not noisy, and this DC machine is noisy. It has not actually uh, do not have rotating parts. These have rotating parts. So vibration problem is not present, and these vibrates. Okay, this maintenance cost is easy and also cost is low. Easy, and I'm writing here low cost. Maintenance got a high and cost is more. Okay, so today we will stop here.